So today we're going to be looking at how to solve equations in algebra. It's first important to know that the goal of solving equations is to get our variable alone on one side of the equation. And our variable in this situation is the letter, because in algebra we like to use letters to represent numbers. So to do this, we're going to use opposite operations. And the opposite operations for adding can be subtracting. And the opposite operation for multiplying is dividing. It's really important to know that the most important thing to remember in solving a linear equation is that whatever you do to one side of the equation, you must do to the other side. So for example, if you want to subtract a number from the left side of the equals sign, well, you need to subtract the same value from the right side to keep it balanced. And if we recall what the order of operations is, we looked at this funny word here, bed mass, in a video from a previous time. This is when we're simplifying expressions. So if we have something like this, first you're going to be looking at, let's take the x out of there. Let's do 4. First, you want to solve this by looking at your brackets first. So what is 4 plus 1? Oh, that's 5. Then you're going to be looking at exponents. What is 5 to the power of 2? Well, that's 25. Then you want to look at whatever happens first from the left to the right, dividing or multiplying. Well, this 3 brings down here. Now let's go up here. 3 times 25. Well, that's going to be 75. And remember this at the start, 2 minus. Well, that's going to be negative 73 because we add and subtract at the end. And that is how we solve an algebraic or simplifying expression. So when we're solving for, say, a value of x, we want to do the opposite, okay? Here's our funny word here again, bed mass. But in order to solve, to get x by itself, for example, we need to do the opposite. So first we're going to do subtracting and adding. Then we're going to look for multiplying and dividing. Then any exponents, and then some brackets. So the word we like to use is called SAMDEB. It's basically the word bed mass backwards. All right, let's try it out. In this situation, we have a one-step equation. So like the word says, it's going to take us one step to solve. So if we were to use this funny word SAMDEB, remember S stands for subtracting, A stands for adding. I don't see any operation here. Then multiplying and dividing is next. And when we look at this negative 2x, we just want this to be x equals something. Right now, this operation is negative 2 times x. And remember, we need to do the opposite operation. So the opposite of multiplying is dividing, letter D. So if we divide both sides by negative 2, we divide this by negative 2, then we see that negative 2 divided by negative 2 is just 1, because anything divided by itself is 1. So here we have 1x equals 8 divided by negative 2. I know that 8 divided by 2 is 4. However, when it's one negative and a positive, it's always going to be a negative. So then our answer is going to be x is equal to negative 4. These are the simple questions that we'll see. If you were unsure if this was the right answer, you could check your work. So here's our original equation. And let's see when x is equal to negative 4. And for example, let's call this the left side. Let's call this the right side. And I'll draw a line here. So if we were to substitute negative 4 in for x, negative 2 times negative 4, negative times a negative will give us a positive. And we know 2 times 4 is 8. And we see that left side equals the right side. Vänstersidan lika högersidan. So that's a way we can check our answer. These are one-step equations. Sometimes we're faced with two-step equations. So as the title says, it's going to take us 2 steps to solve. Let's use our hint with using the word samdeb. So one strategy we can use is looking at this word samdeb and saying, okay, first we're going to use any adding and subtracting. And when we add and subtract, we're trying to get numbers or items on one side of the equals sign onto the other side so that x is by itself. Because at the end of the day, we want the answer to be x equals something. So here we have it's divided by 5 minus 5. So what I can do is I can add 5 to both sides. If I do that, I know that when I add 5 to this side, 5 plus negative 5 is going to equal 0. And I know that 2 plus 5 is going to equal 7. So now we have x divided by 5 equal to 7. Now I need to find a way to get x by itself. Right now we have x divided by 5. The opposite of dividing is multiplying. So if I know I can multiply this by 5, and I can multiply this by 5. When I do this, we have 5 times x is 5x divided by 5. 5 divided by 5 is just 1. So we're left with 1x. And 7 times 5 gives us 35. So our final answer is x is equal to 35. One other strategy we can use, we'll call this strategy 1. This is the Sam-Deb method. Another strategy we can use is called the cover and check method. Cover and check. So let's write the equation here. So x, if we didn't do the first strategy, we're still trying to find x. So this equation here is telling us that a number x, whatever number that may be, divided by 5, then subtract 5 is going to equal 2. So it's also true that if we were to cover this part, all right, we put a question mark here, something minus 5 should equal 2. Something minus 5 should equal 2. Well, I know that this number here can be 7 because I know 7 minus 5 equals 2. So under this question mark should be the answer 7. Okay? And remember, we had x divided by 5 here. So now this turns into a question where we have to find x divided by 5 is equal to 7. Now we need to find what number divided by 5 is equal to 7, or the opposite. 7 times 5 will give us 35. And I know that 35 divided by 5, it does equal 7. So x must be 35. So there's 2 methods you can use to find the answer to a 2-step equation. And again, if you want to check your work, I'll put a check up here. you know that your value x is going to equal 35. And here's your expression. X divided by 5 minus 5 is equal to 2. If you put the number 35 here instead of x, well, 35 divided by 5 is 7. 7 minus 5, well, that's 2. And again, this is what is our left side. This is our right side. And again, our left side equals the right side. Example 3. So now we have a more difficult question. Here we have variables on both sides. So in other words, we have the letter x on both sides. And remember, our goal is to get the letter variable onto one side of the equation. So now this is down to your decision. Either I want all my x's onto the left side, or I want to bring them onto this right side. All right. Personally, what I would do is I would look at this value 3x. I would look at this value 5x. I know that in order to make it so our x's are on the right side of the equation, I need to subtract 3x. If I subtract 3x, well, this is going to be a negative number. That's fine, but a lot of us don't really like working with negative numbers. So let's do the opposite. Let's actually do plus 5x so that we get our x's into the left side. So 5x minus 5x is 0. So we end up with 0 minus 3. 3x plus 5x gives us 8x. And we'll bring this down here, plus 5. Now we have our x's on the left side. Good. Now we need to get everything else onto the right side. And what can we do to do this? Well, we can subtract 5 from both sides. 5 minus 5 is 0. Negative 3, take away 5, is going to equal negative 8. So now we have 8x is equal to negative 8. Finally, to get x alone, we need to do the opposite operation. Right now, this is 8 times x. So the opposite would be to divide it by 8. What you do to one side, you do to the other. 8 divided by 8 is 1. So we're left with 1x is equal to negative 8 divided by 8 is negative 1. There's our answer. In order to check your answer, you can do our left side equals the right side. So we have our x value is negative 1. So 3 times negative 1 plus 5 should be equal to negative 5 times x minus 3. And x was negative 1. Now we solve. 3 times negative 1 is negative 3. Negative 3 plus 5 is 2. Negative 5 times negative 1 is 5. Bring this down. We have 5 minus 3, and that's 2. So the left side equals the right side. Vänstersidan lika högersidan. And we're done. Here we have a question where we have fractions in our equation. And in this step, we call it clearing fractions. So our lives will become easier once we eliminate our fractions and make them whole numbers. So clearing fractions requires us to multiply each side of the equation, each and every term, by the same value, the common denominator. We do not multiply the terms containing fractions. So what I mean by this is we don't make the mistake and only multiply these terms because they have fractions. Because now, if we only multiply, in this case, two terms, then our equation is completely off. Remember, whatever you do to one side of the equation, you do to the other. And that means you do it to each and every term. So when we see these numbers here, 5 and 3, we know that 5 times 3 is 15. So what we can do is we can multiply each term by 15. So we have 15 times 3x, 15 times 2, 15 times x over 3, and 15 times negative 1. So 15 times 3 is 45x divided by 5. 15 times 2 is 30. 15 times x is 15x divided by 3. And 15 times negative 1 is negative 15. These two equations are equivalent, which means we haven't actually done anything to the question. We've just multiplied by a factor of 15. So our equation is still equal because we multiplied each term by 15. The same thing goes for if we had a fraction 1 over 2. That's the same as 2 over 4. It's just multiplied by 2 on both sides. Now let's do some simplification. 45 divided by 5, that's 9. So we have 9x plus 30 is equal to 15 delat med 3 5. So we have 5x minus 15. You could also skip this step here. When you're here, you can do, 15 delat med 5. That's 3. 3 times 3 gives us 9. 9x. All right. Now we're back here at this step. And our goal, remember, get x alone on one side of the equation. So let's do it. I see this 5x, and I want to make it so that we have all of our x's together on the left side. So in order to do this, I will subtract 5x from the right side of the equal sign, and I'll subtract 5x from the left side. We can get really good and do another step in the same part. If I'm getting my x's on this left side, that means I have to get all the other stuff on the right side. And to do this, I can subtract 30. That means I need to subtract 30 here. Now we see that 9x minus 5x will give us 4x. 30 minus 30 is 0. 5x minus 5x is 0. Negative 15, subtract 30, gives us negative 45. So now we have 4x is equal to negative 45. To get x alone, well, we know how to do this. We do the opposite of this operation. If this is 4 times x, well, we can get x alone if we divide it by 4, because we know that 4 divided by 4 is going to equal 1. That means I have to divide this side by 4. So 1x is going to equal, well, this one's not going to come out nice. So let's do our division. We see the negative here and a positive here. So a negative divided by a positive will give us a negative answer. When we do the division, 4 goes into 4 one time. 4 goes into 5 one time with one remainder. Put a 0 there, put our decimal. 4 goes into 10 twice with 2 remaining. 4 goes into 20 5 times. And here's our final answer. Negative 11.25. Or if you keep it in fraction form, Ibrock form, it's going to be negative 45 over 4. Or in, we call this blended form or mixed form, we can say 4 goes into 45 11 times. 11 times, and there'll be 1/4 remaining. So 11 and 1/4, and make that negative. The same. Great. Now we have a question where we have decimals. Okay. Like a lot of you, I don't like to work with decimals because they just mess me up. So we're going to come up with a strategy to solve questions like this. Clearing decimals, it's similar to clearing fractions, but sometimes it can actually be easier and more efficient to clear the decimals from the beginning. This can be done by multiplying everything by powers of 10. 10, 100, 1,000, and so on. This is one method of many. You don't need to do this every time, but this is for those who don't like to deal with the decimals. So obviously, you could answer this question by adding these decimal numbers to both sides and get our answer. We'll draw that afterwards. But when we look at the decimal, we know when we multiply something by a factor of 10 or a power of 10, the decimal will move to the right. Because when I see this, if it's 10 times 2.3, since there's 1 0 here, this decimal is going to move here. So this is actually 23. So this number will become 23. All right. So we can do this, and sometimes this makes our lives a bit easier. So let's multiply everything by 10. So now we have 2.3 times 10. We said that's 23. X. 5.45 times 10. Well, this means our answer will be 54.5. And now we have one number with a decimal, but you can continue multiplying each term by 10 so that it's at the end of the 5. But today we'll show it one step at a time. And this answer is 66. Now we need to get x alone. So let's add 54.5 to both sides. And when we add these, we get 6 plus 4 is 10. 6 plus 5 is 11. Plus 1 is 12. And we have 23x. Now afterwards, you need to get x alone. So we can divide both sides by 23. And our final answer, 23 divided by 23, gives us 1. Now we have 1x is equal to whatever this is. All right. Let's just show at the top before, if we didn't use our strategy. If we had 2.3x minus so without clearing decimals, I'm just going to rewrite the question. So same steps, except we're not going to do this part. So if we add 5.45 to both sides, we'll end up with the answer 12.05 is equal to 2.3x. To get x alone, we can divide it by 2.3. And 2.3 divided by 2.3 is 1. So we end up with 1x is equal to 12.05 divided by 2.3. And when we compare this to this, they are equivalent fractions. This one is multiplied by a factor of 10, which we did there. Good. So that's the end of the video today. I hope you thought this was helpful. And if you did, don't forget to like. And if you haven't done so, subscribe to the channel. Take care, everyone.